12.1 Day 2, example number 1, part B. Again, these problems come from 33 through 46 in your textbook from section 12.1. That's what these examples are similar to. In letter B, we have something that we haven't had happen before. We have the limit as x approaches, and instead of a regular number here, we actually have infinity. When that happens, we are going to build our table a little differently. Usually, we build our table with 7 values in it and look at what happens as you approach that number, whatever our limit is approaching, from both sides. But we can't approach infinity from numbers that are bigger than infinity. Those don't exist. So what our textbook does for this, for any of the ones that have infinity or negative infinity in them, what the book does is it puts in a table, but it does it with 5 values instead of 7. The book always does this for any of the limits where x is approaching infinity or negative infinity. The x values that they choose are 10, 100, 1,000, 10,000, and 100,000 for the limits where x approaches infinity. There's nothing super special about those numbers. What we do need to do, though, is see what is happening as x gets bigger and bigger. And these powers of 10 are super easy to plug in and calculate. So they're nice numbers to evaluate. So I'm going to go through and I'm going to take a look at what we have when we plug these numbers into our calculator. So again, on our calculator, we'd want to go to the y equals in the upper left-hand corner, then type in whatever our equation is. In this problem, we have 1.2 raised to the x power. Again, my calculator is already on Ask Auto for the independent and dependent variables. If you need to fix that, that's in Table Set. But I'm going to go into Table, since mine's already done, and type in those values. There we go. So if you take a look at our calculator, there are some numbers there that are a little bit different. First of all, the first y value, when we plug in 10, gives us a decent number, 6.1917. But if you look at the second number, we have an e in there. It is 8.28 E7. The E that's there, that capital E in the table, what that is actually a times 10. This is in scientific notation. So the calculator is going to say 8.28 E7, but what we really have is 8.28 times 10 to the 7th power. So that's really in scientific notation. And we should translate that E into a times 10 in our table, and you could even multiply it out. So let me move some of those values from our calculator into our table. When I plug in 10, we get 6.1917, decent number. The number here ends up looking like this on our calculator. Again, it was 8.28 E7. What that means for us is this is really 8.28 times 10 to the 7th power. That's how us humans would write it. The calculator is going to use an E. You should write it in the box that way. The other option would be for you to take this decimal and bump it over 7 decimal places. So the calculator will tell you a number in scientific notation with that capital E. You can put either scientific notation or the regular number into your XY table if you'd like. I'm going to do this bottom number, the actual number this time. We don't have a center number this time, so I do need to evaluate all of these. The next number in our list when we plug in 1,000, our calculator said 1.5 E 79. Let me write it out how the calculator has it, then I'll change it. 1.5 E 79. And again, what that E is times 10. So this is 1.5 times 10 to the 79th power. I certainly don't have to write that in the blank. That's a super huge number. So I'm just going to use the scientific notation when I put that in our Y value here. 1.5 times 10 to the 79th power. So either use the regular number or use scientific notation, but don't put it in there with the E value. Our last two numbers actually say error. I'm going to put error here on our table. But it really isn't an error. There is a number there. Our calculator just hasn't been programmed to handle it. So again, calculators are super useful, but if you don't know what they're telling you, it means absolutely nothing. So here's what the calculator is telling us on this one. If you take a look at these first three values, you can see that this is kind of the pattern that's happening. But even if you just evaluate and think about this for a minute, if you have an x value of 10,000 and you're plugging into this equation, you're going to have 1.2 raised to the 10,000th power. So literally what that means is 1.2 times 1.2 times 1.2 times 1.2 times 1.2, 10,000 times. You're not going to get an error with that. It just is going to keep getting multiplied by 1.2 over and over and over again, and the number is going to keep getting bigger and bigger. I can show you what that looks like on the calculator. Let me go out to the main calculations screen, and if I type in 1.2 and I hit enter, the calculator now remembers that 1.2 is the last answer. And what I'd like to do next is I would like to take that last answer and multiply that by 1.2. So if I hit that, this is 1.2 times another 1.2. So this is 1.2 to the second. And if I hit enter again, it's going to take this answer and multiply it by 1.2 again. So 1.2 raised to the third power is 1.782. Raised to the fourth, fifth, 6th, 7th, 8th, 9th, 10th. There's that 1.2 raised to the 10th power that we've already entered into our calculator. And if you keep multiplying by 1.2 over and over and over again, and you hit this button 10,000 times, you're going to end up with a number that gets pretty big. And eventually the calculator is not going to be able to handle it, and it's just going to say, I can't do it anymore. It's an error. So again, it's not actually true. There is a number associated with this value, with this Y value, but the largest number the calculator is programmed to handle is 9.9 raised, 9.9 times 10 to the 99th power. So we have 6.2 roughly here, 82 million, almost 83 million here. 1.5 times 10 to the 79th power. That is a huge, huge number. And then if we went one more place, our exponent here for the 10 would be bigger than 99, and our calculator is not programmed to handle that. So it is an error here. But really what this is this is just a super, super big number. And when you raise it to the 100,000th power, this is going to get even bigger than the last one. So there are two numbers here. Our calculator just can't calculate them, and we don't need to. We just need to be able to evaluate what's happening in the problem. So there is a really big number here, an even bigger number there for our Y values. All right, back to the final answer on this, or getting to the final answer, I guess. We have the limit as x approaches infinity of 1.2 raised to the x power. We're supposed to evaluate that using a table in this section and see what that is equal to. So as our x's get really, really big, as x's get really big, as x's approach infinity, we need to take a look at these y values and see what they are doing and make a prediction about where we think they would go. Well, 6.2, 83 million-ish, 1.5 times 10 to the 79th power, super big number, even bigger number here, even bigger number here. These just keep getting bigger and bigger. So it looks like as these x's get larger, the y values also get larger, and it looks like it's doing it, and they just keep getting bigger and bigger. So my answer for the limit as x approaches infinity of 1.2 to the x power looks like these y values to me are going to infinity.